in the company. Software developer A has gone out of the company for a long time, and then he's been asked to write a function to express eating bread with butter. Now, he could choose to update the earlier function, handle all the dependencies, and whatnot. But what happens more often than not is he writes a function bread butter. He copies the old function. He pastes it, and he updates that function. So here he would introduce a new parameter called butter, and then he would update the value consumed accordingly. Now, a few months later, developer C is given the task of writing a function to express drinking tea with sugar and cream. And now his job is a little bit more complicated, and developer A and B are gone. So if developer B chose to copy the earlier version and not update the first version, you can imagine what developer C would do. He would simply copy the version, and he would make updates as he needs. He would here have to call a function drink, and here unfortunately there is no way of passing the cream and sugar, so he has to, it's probably bad design, and he has to call up function for cream and sugar, and he has to update consumed. Now this scenario is what we call a copy and paste mode of development of functionality, and this happens more often than not because it's easier in the shorter run, and it also is easier to fix bugs because you're focusing only on your task. You don't have to worry about what the older guy did. So let's consider the same scenario, but the developers choose, probably they have more time, and they're more disciplined, and they choose a better mode of doing it. Developer A, he does the same thing. He has no problems. He quits the company. And developer B comes in. He is a bit more responsible. He says, I don't want to create a new function. I don't want to add more lines of code. Everything looks pretty much the same. So what I'll do is I'll add a parameter called spread, and I'll add a parameter called consumed food, and I'll update the function accordingly, and then I'll change the dependencies from wherever the bread butter was called and bread jam was called. Now, the third guy, his job is a little bit more complicated, but he can still go ahead and update the same function. All he has to do is he has to introduce a new function which branches between whether he wants to eat or whether he wants to drink, and then he makes changes accordingly. So right now, in the abstraction version, there is only one function, and we'll see the advantages of it and the disadvantages of it. So we saw two methods, and we knew that there were two methods. What we wanted to do was we wanted to compare the methods. We wanted to see which was easier, which was preferred, and whatnot. So we conducted two user studies. The first user study was we wanted to understand which was the easier way of developing functionality. So what happens here is we picked 5 function pairs from open source repositories, and what we did was we removed one of the function pairs, and we made 5 users sit down in a hall, and we asked them to implement the missing functionality. Now, what we did was we asked 2 of the developers, the users 2 and 3 here, to extend the missing functionality using abstraction only. They were not allowed to copy and paste. And we asked the remaining people to do it using copy and paste, and they were not allowed to use abstraction. So the results were that, let's look at one of the users here. It's pretty obvious to see here that abstraction took more time than copy and paste overall. And some starting examples for user 5, where he could not finish one of the tasks, and he took 55 and 30 minutes, and he could not even start a couple of the tasks. The other guy, the user 2 here, he took 7 for 18 minutes each. And if you notice, the users who were supposed to do copy-paste, they've also done abstraction for some of the tasks. This was because we wanted to know what happens if these users who did copy-paste were asked to abstract the same tasks. They had so much time left in the user study. So, and even there, if you notice, they have taken more time to abstract the same task that they already have prior knowledge over. So this kind of established an already existing belief that we had that copy-paste is quicker. Now, but we also wanted to know what they would have preferred in the code base. So we asked these users, what for these same tasks, now that they've seen the copy-pasted version and the abstracted versions, we wanted to know what they would have preferred to see. Let's say there was some magic and which would extend functionalities automatically, which they would have wanted to see. And in this case, except for task 3 and task 4, the majority of the users prefer favored abstraction over copy-paste. And in fact, only in task 4 was copy-paste favored by the majority of the users. So this kind of established another belief that we had, that abstraction was preferred. Abstraction was preferred as a mode of extending functionality in your code base. So now we've seen a couple of user studies. Let's compare the two modes of extending functionality. One is copy-paste. Of course, the pros are that it is quicker because you don't have to worry about errors during development. You're just focused on what you're doing. You don't have to worry about the dependencies and whatnot. And because of that, it's very effective in the shorter run. The cons are that bug fixing is very tedious during maintenance because let's say there was a bug in one of the clones and it was propagated into the copy-pasted versions. What this is going to do is, if you come to fix one bug, you will have to fix it everywhere. And also this is less readable. Okay. Now abstraction, the pros and cons come out directly out of the pros and cons of copy-paste, except the first one, which is that it is preferred among developers. Developers would like to seek abstracted versions of code. And bug fixing is easier in the longer run because of the reason that I mentioned already. You just have to fix the bugs in one place. It's more readable. But the cons are that it is difficult to abstract with tight deadlines because you need to figure out how you want to abstract. We already saw that you could potentially use a conditional branch, or you could pass in a parameter. There are multiple ways to abstract, and it's not always easy to find out what is the best way to abstract, and the developer A might have done it for whatever reason. And the potential for errors is large because, again, you're touching a code which was already, which probably already had a lot of dependencies, and you will have to change all these dependencies and stuff. So our solution is that we say we'll give you best of both the worlds. The developers, they go ahead and copy paste. They go ahead and copy paste when extending functionality, and they invoke a merging tool that abstracts these functionalities and handles the dependencies accordingly. An example for this would be, assume that we've extracted the ASTs out of these copy-pasted functions. What we would do is we would provide a merged version of these, and these MPs are the merge points. We will discuss them in detail. What they actually mean is that they're the points where you need to execute either one or the other of the AST, and at these merge points, the abstraction should be decided, whether you want to use a conditional or a parameter or a template or whatnot. So,
can I ask you a question? Do you assume that you know that these are copied and pasted? So that 1, 2, and 3, or that 2 and 3 are copied and pasted from one, or do you want to infer that from the code?
That would be a later version, but right now we expect the user to say that, hey, I've copy-pasted this code, and he marks it using annotations, and then we abstract it.
There's plenty of work on clone detection that could suggest these kinds of things, but we don't want to go ahead and make design decisions for the user. We expect that the user might not like that.
Maybe we at least try to find clones and propose them to the user and then allow the user to select which clones to merge.
Right. Yes. Actually, we also use a bit of clone detection for our evaluation, which I've written. So, if you notice, we need ASTs for our merging process. So before describing the merging process, let me get the ASTs out of these. So to extract the ASTs out of these functions, I've simplified them to use simpler names like ABCD and whatnot. And then I've extracted the ASTs out of them. The ASTs are pretty straightforward, and I've removed some distracting details out of the functions to extract the ASTs. And then for the abstracted version, this is what we would want our tool to emit out. For this, again, I've simplified the function. In the simplification, if you notice that the conditional here had only one condition, main dish equal to bread, but here it has function ID equal to 1 and function ID equal to 2. This is because the bread one came from two of these functions. This can happen in the real scenario. So we are not, in the abstract version of it, we are not differentiating between whether it was bread or tea. We just have 3 functions, and if the function ID was 1 or 2, it has to do one of these, and if the function ID was 3, it has to take another path. Now, so the merged version, that is why it would look something like this. And as I told you, I was talking about merge points, and one of the merge points is here if function ID is 1 and function ID is 2 is one of the merge point, where it would either branch into B or B2. And another merge point is the B param. Here it's not a conditional, but it's still a merge point because it diverges between, it executes either the butter version or the jam version with the parameter. Okay, now let's look into the merging process. So the overview of the merging process is very simple. We gather the nodes that are common to all the ASTs. In this case, it will be A, X, Y, and Z, which are marked in white. And we gather the merge points. And of course, we cannot just get the merge points. We need more information about the merge points. So what we do here is we gather the merge points. We gather the nodes. We gather the nodes that are to be executed on those merge points and the ASTs that they come from, so that decisions can be taken. So for example, here it would be B and B2, and we can, the tool and the user combined can take a decision on how to merge these two nodes. So the easier bit was gathering the common nodes. The more interesting bit, the more exciting bit is the thing about identifying merge points. So how do we identify these merge points? So for identifying these merge points, if you notice, the first information we need is where are these nodes and which ASTs they come from. So for example, the ASTs the nodes B and C are actually common to both AST1 and AST2. The node B2 and N and F3 are only there in AST3. So for this, we introduce the notion of unique sets. Unique sets are nothing but the set of nodes that are unique to a particular set of ASTs. So basically, this would give a categorization of what are the nodes and where they come from. So for the unique sets for these ASTs would be, unique set of AST1 would be B and F1, which are marked in a kind of violet. The unique set of AST2 would be E and F2, which would be marked in a kind of yellow, And the unique set of AST3 would be B, B2, N, and F3, which we have marked in green. And the unique set of AST1 and 2 is B and C, as we discussed. Now, if you notice, there are no unique sets for AST23 or AST13 because they are empty. And the unique set of AST123 would simply be the common nodes A, X, Y, Z. So now the first step would be identifying the unique sets of all subsets of these ASTs. Right? So, but they are not enough because if you notice, the unique sets are not exactly the merge points because the unique set of AST1 and 2 would be B, C, and there is no merge point in C. So we need to filter it further. So we introduce the notion of root sets where we find out the nodes where a merge is needed. And this we do by collecting all the nodes in a set, all the nodes in each of these unique sets which have no parent nodes. So for example, in the unique set of B, AST1 and 2, which is B and C, B has no parent in the set, but C has a parent which is B in the set. So what we do here is we filter out the unique sets into root sets. Now, the root sets of AST1, 2, 3 are the same as the unique sets because, for example, consider D and F1 in the unique set of AST1. Both of them don't have a parent in the set. So that's why the root set is the same as the unique set. And the only difference between the root set and the unique set is for AST1, 2, which is filtered down to B. Now, if you notice, the root sets are exactly the places where a merge has happened. So that's the part of identifying merge point. We collect unique sets, then we filter them into root sets, and these root sets, every available position in these root sets are an opportunity for a merge. And for each of the merge points, a resolution pattern is offered to the user. Before we get to that, are there any questions?
Sure. What happens if two pieces of code are identical, except for the fact that one is using the loop, for example, or some other kind of nesting construct, let's say conditional? How would that work in this case? Let's see that.
What do you mean? If two sets of code?
Well, let's say you have one block with statements ABC, and the other one has while whatever ABC, right? So you have the same code, but it's nested in some other statement. Then I don't see how the matching would work.
So, for example, if you notice the node N, because the node n has been introduced in between, like the while construct. While would branch inside, but n has basically made insertion inside, and the information about f1, f2, f3 needs to be gathered because the position of f3 is a little different from f1 and f2 in this case. So for that, that is an implementation detail, and we handle it using a concept called edit maps. So which basically give you the information about the nodes that were inserted. And so a code like this, while ABC and there is ABC, what it would do is it would simply say that while was inserted and ABC are the same. It would not give you. So it's kind of the number of edit operations that are needed to move from one AST to another.
But what would the final code then look like after the merge?
The final code here, in this case, it could simply be pulling out a method for ABC and then putting it in.
Yeah.
So this is the part where the resolution pattern is interesting because for each of the kind of differences, we need to resolve them differently.
Okay.
And that is why the resolution pattern is actually offered to the user. The tool does not make the decision here. We identify the merge points. We say, hey, we've identified merge points. We have these information about the merge points, and you choose the resolution pattern. You choose how to resolve it. Because there could be multiple ways to resolve the same kind of difference. Now,
just one question about that. So what I don't understand is that this seems to be more syntactic merge. So we have seen the merge code example, which still looks kind of messy because you have essentially a check whether it's function A then do this, if it's function B do this. So isn't it the same effort for the developer to afterwards clean this up? For instance, rename this function to say, okay, if let's say I'm eating bread with something healthy, then do this, to actually have an abstraction that buys you something, because an abstraction in itself is not better than copy and paste code.
Not always, but if the code is large enough. So these are things that we'll discuss in the resolution pattern. So right now my question was, I'll surely discuss that case, and the example that was chosen was kind of extreme to drive home the point. This is not something that probably would be merged.
The algorithm can merge it.
Yes. So the point is that we can merge it there. It was an extreme case, but what we have merged is a couple of examples that I'll show you, and yeah. Okay. So I wanted to know if there are any questions regarding identifying the root sets and unique sets, and okay. So now it's good that these people brought it up, because now it raises the question of how to resolve these merge points, and that is why we. The tool doesn't make a decision here, it is passed to the user, and so that is where the concept of a resolution pattern comes in. If you notice, the RPs here, the MP is now changed to the RP, because now the RP would take in a lot of information inside it. So at this merge point, the resolution pattern, the function would tell the user that, hey, 1.2 executes B, and AST3 executes B2. So it also has information about the ASTs they come from, each of the execution choices. So, and let me go back to the previous example and drive home again what is a resolution pattern. A resolution pattern, as we saw, is a way to resolve each kind of differences. Here, the resolution pattern here is a conditional branch, where it said if it's from these two functions, then execute this code. The resolution pattern here is a constant passed as a parameter. Before it was bread and butter. Now an extra parameter is passed which executes either bread or butter. So this is just a couple of examples of how differences can be resolved. The approach we took was basically a resolution pattern, as we said, is a code transformation pattern that resolves merging certain kinds of nodes. The kinds of nodes here is very important, because right now the approach offers resolution patterns based on the type of nodes. If the type of nodes that are to be executed are constants, then it offers either passing an extra parameter or a global field. If the type of nodes are statements, then the resolution patterns that are offered are conditional branches or switch statements. If the type of nodes are actually types itself, they can be resolved using template parameter. So we had a small table. This is a little bit more detailed. And so we used this table to offer resolution patterns. So if the difference was statement, so merge points are identified for each of these merge points. Based on the type of these nodes, a resolution pattern was offered to the user. Of course, this can be extended into a bigger list, but right now for the research prototype, this is the table that we use. So now for a very interesting bit to talk about real examples of merges to answer the question. So this was one of the merges that we performed on Facebook's RocketsDB. It's a very simple code with, I think it was actually more than 50 lines of code. There was a lot of common code, and the only difference was the statement which updated the status. So we believe that we applied our tool, and we chose the switch. We were the ones who supplied the input. We said that resolve it using the switch pattern, switch pattern, and then it resolved it like this, and it was merged back into Facebook's RocketsDB. We will look at the results of the merges later. So this was one example of a merge where two statements were resolved using a switch statement. Now another merge is from the RethinkDB. This is also a top trending open source repository in GitHub. The difference here is there are two functions, which one creates an int array and one creates a double array, and the only difference is the type of the first argument. One is an int and one is a double, int star and a double star. So this was resolved using a template. We applied our tool, and we said, when the tool asked us for an input, we said use the template arguments to resolve this, and this was resolved using the template. So these are a couple of examples. Now let's look at detail how we actually evaluated our approach. What we did was, before I get into this, let me introduce what is a pull request. I'm sure most of you know it, but still. Of course, all of you know that there are open source repositories, and GitHub is one of the open source repository websites. And so what you can do is you can contribute to these open source repositories. You can check out their code. You can make changes to them, optimizations, or in this case, source code cleanup, and you can submit pull requests, meaning we've done something nice, would you like to pull it back? And so that's what we did. But we did it in two phases. The first phase was, we used a clone detector for this, of course, you know, this is where the clone detector comes in. We used a clone detector to find out functions, interesting functions to merge. And we applied it on, so we, basically there was no restrictions on the clone we detected. So we said, hey, throw up all functions, whatever sizes they are, small, big, and then even if the differences between them are really big. What we did was we picked out function pairs because the first version of the tool worked only on function pairs. This was a limitation which we addressed in the second phase. So we merged them using our tool. We chose appropriate resolution patterns because we did not have the liberty of interacting with them so much. And then we submitted pull requests. And out of 8 abstractions we submitted, only 1 was accepted. And this we believe was because of the problem that he mentioned, which was we merged functions that were too small with too large differences. So what it probably looks something like if do all this, else do all this. And so that's the reason we, so basically the first tool was only capable, but we did not apply it on interesting examples. The second one was we learned from our mistakes. What we did was we said, let's collect very big functions with very small differences. And then, so the phase 1 happened with top trending repositories in GitHub in December 2014. And the second phase happened recently in top trending repositories in February 2014. We chose top trending repositories because we wanted to know how acceptable our merges are in really a good industry level code. So most of them were from Google and Facebook, and so we got really good positive results. We submitted 10 abstractions, out of which 9 were accepted and 1 was rejected. We tried getting back to the person on why he rejected it, but there was not a lot of response. And if you notice, there are some pending stuff. At least in the first phase, there were like 4 of them were pending. This we believe is because developers are busy with their work and tending to pull requests is not their only task. And that is also one of the reasons we did not want to bug them with a lot of pull requests for our initial evaluation of the research prototype. So, also the interesting thing is we got responses from phase 1 rejected results, and their concerns were that we did not save a lot of lines of code as they would have liked, and it was too small a change for a pull request of their quality. And so, yeah, so that was the reason.
Just a question.
Sure.
How did you pick the ones that you submitted? So you said there's a manual step. You expect the developer to decide whether it's worth.
Yes. So that we did right now.
Did you filter the 10 that looked most promising?
No, we just picked them out of random. So in phase 2, what we did was we just changed our thresholds of. We changed the thresholds of the function sizes and the differences between them, and we collected clones. And out of these clone groups, all we did was pick stuff in random and apply it on a merging tool. And of course, there is a user interaction that is needed on the resolution pattern. Here, we did not have the liberty of talking with those people, so we just we wanted to evaluate it. We chose the resolution pattern we believed was the most appropriate, and we submitted it back, and they were accepted.
And how many resolution you had to do? I mean, on average for each subject, like one per subject? Or?
Mostly one.
One.
Sometimes two. So yeah, the examples were just to illustrate the point that our approach can handle multiple merge points and multiple resolution patterns at the same time, should it happen. So that was our approach and the results. So the first future work will be building a complete tool. What we would do is right now we have a research prototype. We want to build an Eclipse plugin out of it, and then we want results on the user interaction, what resolution patterns were chosen and how they merged it. So for that, we would like to distribute it as a plugin and record user statistics and see if people like using such a tool. And the second would be my PhD work, which is designing a transformation language to express such non-trivial refactorings. So one of the non-trivial refactorings is what we saw, which is merging copy-pasted tool. Now, the interesting bit about this designing a language for this example is that someone who wants to introduce a new resolution pattern, he doesn't have to come in and write more code in the source. He just has to extend the language and say, hey, this is one of the new resolution patterns, and incorporate it as part of the refactorings. And the bigger scheme of things is we also observed other interesting non-trivial refactorings like API migrations, and these needed to factor in a lot of other interesting information. Of course, here the refactorings involved global changes, like if needed to update superclasses and headers and stuff like that. In API migrations, the refactorings involved factoring in flow information and stuff like that. I'm not getting into the details of this in this talk, but so the eventual goal is to design a language that can express such non-trivial refactorings and then evaluate it. So, to conclude, copy-paste offers a quicker, more short-term beneficial mode of development. Abstraction offers a more long-term beneficial, maintenance-friendly approach to development. And we propose to offer the best of both worlds. We say developers, you go ahead and copy-paste. We'd abstract it for you, and you can decide whether you want to keep the abstracted version or the copy-pasted version, or how you want to abstract. And then we also found that in the initial evaluation, we found that abstractions made by a tool were of sufficiently good quality to be accepted by majority of the industry-level codes. So, feedback, questions, and
thanks for following.